All right, so next thing is actually using the Pythagorean theorem in real life, which this is probably one of the more applicable things that you can do with the Pythagorean theorem. Um, I know a lot of times in math, especially if you think algebra, there's not a whole lot of times where you're actually able to use what you do in math class. Geometry is one of the exceptions, especially when you start doing stuff with area and surface area and volume and whatnot. But this is one time in my life recently that I've used the Pythagorean theorem, and I want to just kind of tell you guys about it. So before we get into that, there's three words that I need you to know, or at least remind you, because a lot of people have a tendency to get a couple of these confused. Horizontal distances are left and right, even with the ground. Horizontal, vertical, straight up and down, and diagonal is the distance between the two, right, on a slant. So just be aware of those. So back in 2016, when I moved down here to Marion and bought my house, it was October. It was actually right before Halloween when my wife and I moved into our house with our two kids at the time. Have three now. But that Thanksgiving, I wanted to decorate my house. I wanted to put Christmas lights up for the first time in my adult life. I love Christmas lights. I wanted to decorate my house with them. So what this is here is it's kind of a mock-up of my garage leading up to my house. So there's these little carriage lights on the side and then the big garage door in the middle. And this peak, there's actually two of them, very, very similar. There's the one on the garage, and then there's the one next to it that's the main part of the house, which you'll see a picture of here in a minute. What I wanted to do was put Christmas lights on the diagonal parts of this, going up the peak and then down the peak, which are the same size. What I wanted to do, though, is I didn't want to buy more lights than I needed, and I wanted to make sure that I had enough. Again, didn't want to get on my roof. So what I did, and just see if you can kind of follow along here, I measured on the ground, right? Safe on the ground, not going to fall down on the ground. I measured the distance across the front of my garage. Honestly, I've forgotten those numbers, but for the sake of this problem, let's say across the bottom here, all the way across the bottom, it was 30 feet. Okay, so 30 feet across the bottom, all the way across the bottom on the front. Now, what I want to focus on up here is this pair of triangles at the top. Notice they are right triangles. That means that this 30 feet, there was 15 feet over here and 15 feet over here. Okay, the next thing that I needed to know, if I'm trying to calculate this distance over here, I need to know how tall this vertical piece of this triangle is. So in order to do that, I ran my tape measure. If nice stiff tape measure, you can run all the way up to the top of the peak. So from there to here, I figured out, well, I had to measure from here all the way to the ground, and then I subtracted off the height of the garage, but I figured that ought to be 6 feet. So using the Pythagorean theorem, and yes, I did do this. I grabbed the calculator on my phone and I did the math standing out there in my yard. I set up the Pythagorean theorem, knowing that the vertical piece was 6 and the horizontal piece was 15, and I calculated that diagonal piece. So that's 36 and 225. Grab my calculator again. I'm just not standing out in the yard this time. I calculated this here to be 16.2, but 16 feet. That means that this piece over here was also 16.2 feet. So to go up the peak and back down, I needed 32.5 feet of lights. Well, I happen to have a 50-foot strand. So I had more than enough. I was able to go around a gutter and kind of use the extra. This was the first year, 2016. So I enjoyed the way that looked so much. The next year, I bought more lights, and it's kind of expanded a little bit. This was a picture. Hang on, I got it here. This is what it ultimately kind of wound up looking like. But I took this picture of my house. This was last year. Over here by the garage, you can still see there's the original strand, and then I just added more to it, and I ran around the whole back of the house, and I think it looks pretty cool. I enjoy doing it. But I actually stood out in my front yard in the driveway, and I used the Pythagorean theorem to figure this out that first year. So there are some real applications for this. And we're just going to do a couple of problems here so you guys can do some real math. Mr. Richard owns an orchard that has a rectangular fence. Okay. The orchard is 36 yards long and 18 yards wide. If he walks across the diagonal length of the orchard, how much distance would he cover? It's kind of a boring use of it, but I've got a leg here and a leg here. I'm trying to calculate the hypotenuse. Hopefully by this point you're okay using those exponent keys on your calculator. This is 1,620 for my hypotenuse squared. So when I square root that, it is 40.2 yards. Okay, again with the units, I'm not a real stickler on the units. It's yards in the problem. Your answer is going to be yards. Okay, this one, I've got a 15-foot tree casting an 8-foot shadow. We're trying to calculate from the tip of the tree to the tip of the shadow. So those are my legs again, 8 squared and 15 squared. We're looking for the hypotenuse. Excuse me. That's 289. So when I square root that, it is 17. Okay, pay attention to what you're given. If you're given the diagonal length of anything, that means you have the hypotenuse. So you're trying to work backwards and find the leg. If you've got horizontal and vertical, you're trying to find the diagonal. So it really kind of changes the setup depending on what you're given.